forces its way into the soft glass. So now we have an air bubble maybe the size of a golf ball in that material. We shape it and organize it, and then we have to let this cool down. This is not very much glass. It's only enough to make something small, like a little drinking cup. But to make something larger, we have to build the material up in layers. So once this cools down, we can go back to our furnace, and we can get a second layer, or as we call it, a gather of glass. So Katie uses some compressed air to force cool the bubble, so that we can speed up that cooling process, so that it will become rigid. I'll show you an animation on our TV screens so you can see what it looks like inside of our furnace. This furnace holds 1,000 pounds of molten glass. It stays on all the time, 24/7. It's been running non-stop for nearly 8 years now. For about 7.5 years this furnace has been running. So all the glass that sits in a large ceramic bowl, we push the pipe beneath the surface, and we turn and spool the additional layers right on top. So as we're collecting glass and gathering glass, the level of the furnace gets lower and lower, and every few days we'll add more material into the furnace. So we get our glass from a company in Washington State. They mix and melt all the raw materials, and they send us 50-pound bags of glass that's been melted once. So we get these little cubes of glass, we shovel that into the furnace, and we melt it down. So yesterday we put in, I think it was 100 pounds, maybe 150 pounds of glass in the evening. But all that glass on the end of the pipe gets organized by a wooden scoop called a block. That wood tool shapes, centers, and cools the fresh layer of glass. And that wood tool is soaked in water. Soaked in water. So the water glides on a layer of steam, and we can shape the glass without burning up that tool really rapidly. So Katie shapes the glass. She held the pipe downward so that the glass was up at an angle. And then when she blows through the pipe, it kind of blows the bubble all the way to the end of the glass that she has there on the end of the pipe. So it sets up a really even and really uniform bubble. So that tells me that she's probably going to go into an optic mold. So we have a series of molds here. We've got a couple in front of this box. We have some under our steel table here. So when you have a really uniform bubble, you can drop it into the mold and inflate and pick up the texture within that mold. So I think that's her next step in her next plan. So we've got a couple different molds. She'll drop the glass into the mold and inflate one that's inside of the mold. So it fills in, picks up the texture, and now we have all these vertical ribs on the surface of the glass. So we've got a view inside the reheating furnace, and this is where you can really see the texture quite well, and when it's going to be most prominent because it's fresh out of the mold. But as we begin to expand and inflate the glass, that texture will be less prominent. It's not going to be as sharp on the surface. But we also need to work quickly, because if we overheat the glass, we can melt that texture away. Glass naturally wants to ball up to become smooth and round. But instead of keeping that texture vertical like it was out of the mold, Katie's twisting the texture. So she used a pair of shears, and she grabbed the glass. She continued to turn the pipe, and by holding the glass in place and turning the pipe, it twists that texture around the bubble. So we make this pattern quite often, especially in our early days of learning how to blow glass, because we do have to make sure we don't overheat the glass and lose the texture. So we do this a lot on cups, and we call it a twisty cup. And we call this a twisted optic, because we twisted the texture in that optical mold. So we call it an optic because it changes the optical properties, changes the way that light interacts with the glass, the way it's reflected and refracted. So a little bit of stretching, a little bit of inflating. We do this in steps and stages. We don't want to just blow one time really hard, because we can actually blow this glass up very big and very thin. And if we overinflate it too much too quickly, it can kind of collapse in on itself. It'll look a little bit like a raisin. Or if we try really hard, we can blow this up and actually make it so thin that it will pop. So we do that just a little bit at a time. Now, as the glass is outside of the heat source, it's always cooling down. As we tool the glass, we're cooling down the glass even faster. And then as we stretch and inflate the glass and it gets thinner and thinner, it's going to cool faster as well. And that's just because of the thermal mass. So the thinner the glass is, the faster it cools. The thicker the glass is, the longer it stays hot. Just like a spoonful of soup is going to cool much faster than an entire bowl of soup. So Katie used a torch there. We call that the hot torch. It's oxygen and propane. And that torch, we can turn it up to nearly 4,000 degrees, and we can focus the heat really specifically in one area. Katie focused the heat on the tip of the bubble, which is going to become the bottom of this piece. So she flattened it to create the bottom. So we're going to break the glass from the blowpipe. Katie also made a constriction just off the end of the pipe. And that constriction, that's our designated breaking point. It's that little crease in the glass. It's like the crease in a chocolate bar. Does the chocolate bar break? This will tell our glasswork to break. So we'll connect this temporary handle, this is called a puntee, right to the bottom, and then we can break the glass from the blowpipe Katie has onto this puntee that I've brought, and then we can work on the top. So to break the glass free from the blowpipe with that constriction, we'll thermally stress the glass. We can use a steel tool to chill it. We can also use drip water. But we're cooling the glass rapidly, creating thermal stress. Little cracks and a light tap is all it takes to break that piece free from the blowpipe. So smooth and successful transfer. Now well done. And I have access to the top and to the opening. So that glass, it breaks like glass would break at home. It's still sharp, it's still jagged along that top edge, but as we heat it, it will naturally soften and round back out. The one thing I didn't mention was how we would add color. If Katie wanted to add color to this piece, we typically do that at the very beginning of the process. We have these crushed chips, these little pieces of glass color that are maybe the size of table salt. We can roll the molten glass across these pieces and they'll stick like sprinkles on an ice cream cone, and then we can melt them in smooth. So it's a fast, easy way to apply color to anything that we're making. And we have over 150 colors to choose from. So a lot of different choices, a lot of variety. And we order that from a company in Germany. So they've been making glass color for close to 200 years. So they're very good at it. It's very consistent. And it's just easy for us to buy it from them. But once that glass heats up, once it becomes soft again, we can continue shaping it at the bench. But of course, because that glass has been stretched, it is thin, it's cooling very rapidly, we maybe have 15 or 20 seconds to work on the glass every time we sit down at the bench. So Katie's always thinking several steps ahead. We always know what it is that we're going to make, but she's even prepared the bench with the tools that she needs. So she got a pair of shears, so you'll see her use a pair of shears in a moment. She's going to stretch, pinch the glass with a pair of tweezers, and then those shears that she got, she can use to cut the glass to create a pour spout. So Katie's making a pitcher, and she cuts through the glass with those shears to create a pour spout. So by intentionally cutting that unevenly, it defines where the spout would be. So it seems unusual to be able to cut through glass because we're all familiar with glass in its normal rigid state. But while glass is hot, it is pretty easy to cut through. It's maybe like cutting through an orange peel or a sponge. There's kind of soft, squishy resistance to the glass. But again, we have to do that very quickly for two reasons. One is that the glass is cooling rapidly, and then the other one is that as we cut the glass, our hand is very close to it, and it is very hot. So we'll cut through the glass quite rapidly. So Katie will finalize the shape of the spout. She gave me a little head nod, and that's my cue to get additional glass one more time. But this time, this glass will be for the handle. So that's typically the last thing that we add to pieces that we make, because once we add a handle, we really throw off the weight distribution of the piece. So I'll collect some glass, and if I just delivered this hot glob of glass, it would be very difficult for Katie to turn it into a nice handle. So I'll shape this up. It's a little bit like rolling clay or Play-Doh on a table. You roll it into a cylinder. We can roll the glass into a cylinder as well. So just predetermines the shape and cools the glass to give it some structure. So Katie's taking short heats, maintaining the temperature of that pitcher. Uses that torch to focus a little heat on just the bottom section where that puntee is attached, because that is also a delicate connection point. So we'll meet back at the bench. I'll take one brief reheat just to make sure this is nice and hot. And then Katie will attach this to the vessel. So handles are a little bit like sculpting with a wet noodle. We have to put this on very hot so that it will permanently fuse, which is important because we want the glass to stick and fuse and be able to support the weight of the pitcher plus whatever liquid goes inside. So Katie can stretch the handle. She cuts that free, and then she can pinch and flip the glass and place that down to make a nice little handle. So that handle's still very hot. You can see how much it's moving still. She can use the tweezers to stretch that out, make it nice and elegant. She'll take a brief reheat. This reheat will be probably one of the last heats of the process. But the handle is the hottest thing into the furnace, will be the hottest thing back out of the furnace. So she'll have a couple final adjustments that she can make to the handle. And then the last step is to slowly cool this glass. Everything that we make has to go through a slow cooling process called annealing. If we just let this glass sit out in the open air, it will cool too rapidly. And if that happens, the glass will shrink and contract, and it will crack and break. So we'll put it into a 900-degree oven. This is our last show of the day, so we'll run a program to cool the glass, and we will see this again tomorrow. So a little bit of water at that Punty connection creates that stress. That tap breaks it free, and there it is. One last look at the picture. Beautiful job. I see you give Katie a big round of applause for a gorgeous picture. A small round of applause. It's a small crowd, that's all right. And there we go. So that's going to wrap it up for our demonstration. If you have any questions, feel free to stick around. Be happy to chat with you and answer those. Otherwise, you still have about 45 minutes to explore the museum. Thank you so much.